real talk. Real talk. When do you want to do your test? Now, so I'll give you like what I had planned, but my plans are always open to change, and they do all the time. Well, yeah, but also just me. I planned that we would do 411 today, 412 tomorrow, and then start the test. Well, first off, I'll take questions from closure today if you guys have any. But start the test on Thursday, see how far we get, and try to wrap it up by Friday because half of you are going to be gone for Stone Lab Monday, Tuesday, and then it's Discovery Days, Wednesday, Thursday, and then we're out of school on Friday. And by the time we come back the next week, that would have been 2 weeks from the last time that you did anything in Chapter 3, hence like yesterday, right? So, if you really have a hardcore opinion to the opposite or of a different plan, you have to be able to defend the why.
I was wondering if you could give me like a tan worksheet because I want to make sure that I have it.
Dude, go to Khan Academy and just practice tangent.
Yes.
They've got better stuff than I could make in like a quick amount of time.
So what would I look up?
You can probably just Google Khan Academy tangent work.
Satya, you said you understand the tangent.
I understand, but I need more practice.
Oh, I see.
He has level 1 practice. He has level 1 knowledge.
Why what?
The red border thing, the red and white is like circles.
Yeah, that's the recording.
Oh, yeah.
So these are videos, and then these are practice. Right, so trig ratios. I mean, that's what you're practicing is trig ratios, but we've only done tangent. So the only concern is that if you go to do some like trig practice, it's potentially going to ask you for all of them. Sine, cosine, and tangent.
Are we learning the other?
We will. Now, really, if we're being honest about like what the trig ratios do for us, just so my triangle doesn't stink, I'm going to pull up one of these and then we're going to talk about this real quick. So, when we talk about tangents, right, if we take tangent of angle A here, we know what that's telling us now. Tangent of this angle, let's call it 40, compares the rise and the run of the slope. The only way that sine and cosine are different
it's the opposite.
Let's say you know how high the handicap ramp needs to go, and you know how long the handicap ramp is, but what we don't know is how much of the ground it is actually going to take up.
Yeah.
So we don't need it. We don't know it. And let's say I didn't know the angle, which I sure hope a handicap ramp is not 40 degrees. That would be a very fun ride. We inverse, right? We inverse sine, plug in the opposite and the hypotenuse, and then we get our angle out. Right, hold on, just hang on to it for a second. Then cosine is just the adjacent length compared to the hypotenuse length. That's it. B over C. Yeah, here. So in this image, this would be B over C. This is A over C. And then tangent is always your A and B. Rise to run. Yes.
I want to try to ask this in the best explained way. So would this be tan of 50 times the length of B to find out A?
It's a 4.
You said 50.
Oh, no, I meant 40.
Yeah. Well, so you can work with 50.
Well, yeah, but that would find out B, right?
So if we know the degree measure, we can find out either of them, right? So if I have tangent of 40 equals my A compared to my B,
We just switch rise to run, rise.
A equals B times tan of 40. Yes, you are, because I can multiply both sides by B, and A will equal B times tan of 40.
So it's just the adjacent angle times tan. Wait, No, it's tan of adjacent angle.
What are you trying to solve? Sorry, what's your objective? Are you trying to be able to determine a length?
I want to find a formula.
This is your,
Okay.
so the formula. No, I got you. You're good. The formula is tangent of theta equals opposite over adjacent.
But the opposite over adjacent is what I don't understand.
From there, we can manipulate it however we want because it's a ratio. Yeah, I'll give it a shot. You guys can sometimes explain better than I can.
This is theta, right?
I know that.
Side.
That's the adjacent.
This is the adjacent.
I know.
So, okay. So what you can do,
As long as it's washed.
you have adjacent tan. This is length. Okay. Tan of theta
Yeah, we had this
equals the opposite side.
put on.
Here, I got it.
No, I don't want you to explain. So here, give me the So would it be if this? Let's say this is 40. So would it be tan
bring like a photographer
40 equals? Let's say this is 5 and this is 4. Would it be tan
Or
40
you could
equals
just
5
ask me
and
to be
4?
on the test.
No, because tangent is that simple.
No,
Where's
no,
the
yeah,
button? Because there's side lengths
Go.
Okay, so let's
That
say,
is
let's say
assuming that
this
this
is
is
a
actually
problem.
what it's called.
So
What do you
let's say-
mean with soul?
Okay, if
This
you
is
guys keep
40,
doing
this
that
is
name in
45.
front of the
You're
board.
making it worse.
All of
This
you
side,
guys
yeah,
are
this
being-
side. What do you
that
think?
side.
You would do
I
tan
understand this.
I'm just gonna give you some
40.
time to argue.
times 5. Very bad.
Here, you're trying to get to height. Okay.
So this is
You have this line.
You have to have something in here.
You guys are both talking about.
Sit down.
Guys, understand you have to have something
Can I
in here.
just
Love you guys. Sit down.
talk to you about
I got it.
So,
I got it.
Your confusion is confusing us. You're supposed to stop the Q-tip when you feel resistance.
Get out, shoot graphic.
Yeah.
Already done.
Satya, I'm gonna make you feel better. Don't worry.
Okay, Satya.
You were helping.
Nobody talking. Zero. No words out of anybody's mouth. Not even mine.
I know how to do that.
No words.
What's this then?
Green just seems hard to see up here. Okay. Infer.
I think they're 99-degree angles.
Why, thank you, Mr. Hudson. You have completed them.
If you can do all three of these, you understand.
Wouldn't be good for the test. So none of these have anything to do with cosine.
I just made these up out of nowhere.
Do they have anything to do with cosine?
I'm about to bring it full circle.
Oh, do we have to use cosine rules?
No. Not yet. We come back to trig.
Okay, well.
Oh, are
Whether
you
any of,
concerned about the test?
no, I just wondered whether any of these
The only thing you'll be
has
asked to do right
anything
now
to
is
do with
to-
sine or cosine.
yes, most definitely.
Okay.
Because then find the hypotenuse length of all of these. So
These
up
ones
here-
have to do with, these ones have to do with cosine and
A little
sine.
messed up the answer. Are we supposed to be in classic or not?
Mr. Hudson, these
depends if you want your
triangles,
answer spit out as radians or
these
degrees.
triangles have
Like if you're in radians, you need to make the choice of classic or math current. But if you're getting your answer as degrees, I don't think it really makes a difference. So as long as you're set in degrees. So like, what'd you get for this angle?
18.43.
18.43.
How did you get it? I know it's second
Because
tan.
you do second tan and then rise over run.
Oh.
Oh.
Inverse tangent, right? So start calling it what it is. I know the button you hit is second, but we're using the inverse of the tangent function, and then we're plugging in our slope. Now, eyes.
I got 18.
Oh, 18 point.
Never mind.
Eyes. If asked to find the length of the hypotenuse. Now we need to involve cosine or sine. Because, hang on to it. Or, yeah, Pythagorean theorem. Yeah, we got that. But, so, let's assume now we don't know this. And I can't Pythagorean theorem. Now, we could apply tangent, figure out this length, then apply the Pythagorean theorem and figure out that length. But we don't need to. Because we know the adjacent. And we know the angle, and I'm trying to find the hypotenuse. Based off what we have. This was absolutely not what I was planning to do today, by the way. Cosine relates adjacent and hypotenuse, right? As we just talked about. Ka in the so, ka, toa. Ka, C-A-H. Adjacent hypotenuse. Sine would compare opposite hypotenuse. So if I put in cosine of 18, like 0.43, right? Equals 12 over my unknown hypotenuse. Do in your calculator 12 divided by cosine of 18. Sorry, this is written out really poorly. This is cosine of 18 equals 12 over hypotenuse. This is where cosine.
6175466.
12.6.
12.6487465.
12.6.
Okay, I have one more question.
So, you don't need, like right now where we are in CPM, you don't need to really understand cosine and sine. But the only difference it has versus tangent is what lengths it compares.
So, which one is the adjacent angle of side question in B? The one that's not the
Yeah,
hypotenuse.
Both angles are adjacent.
No, Satya, what you have to do is the side that you're trying to solve for has to be the up and down one. You got to turn it that way.
Okay.
So the 10's on the bottom, and you have to find that angle.
This? No, you
using
don't.
theory.
No, you don't.
No, you really
That's what I
don't.
do.
So, you
It's
can.
one
turn it
seat
that way.
way.
So I'm not telling you you're wrong. You can do what you said.
No,
You don't
hold on.
have to.
Yeah.
Because tangent relates opposite to adjacent. I think what you're getting stuck on is adjacent just means next to it and touching, but in our use here, it means not hypotenuse. Because the hypotenuse is also adjacent. But I can do tangent of this exactly how it stands. Tangent of 84 equals 10 over question mark, and then swap the question mark and the tangent.
So 10 divided by 10, 84.
10 divided by tangent of 84. You just set up the ratio comparison. So this becomes...
How about we 10 times 10?
No, so set up your, like, always set up the original. And I think where you might be getting stuck is you guys are trying to, like, do too little. Always write it out. Tangent of 84 equals the opposite side over the adjacent side.
What do you mean by opposite side?
Opposite
angle.
across
So
from
like,
the angle. Adjacent
This is
means
a
the
lot.
one touching.
Oh.
Opposites across from it, not touching the angle. Adjacent is touching the angle, not the hypotenuse.
So it would be 10 divided by 10. I get it. Why 10 divided?
Because this is really tangent of 84 over 1, and when I cross multiply and then divide to solve, I'm going to need to divide, quote unquote, both sides by tangent of 84 to get the variable by itself.
So it's 1.05.
Probably. I mean, it's going to be something tiny because I made that angle so big. 1.05. There you go. So yes, verification. Any other like questions that aren't just like, but I just don't get it.
What are you
Like,
supposed to find?
actual questions.
What are you supposed to find in the
Either. So, given two pieces of information, what we're really coming down to, like the nitty gritty of trig, is if you know a right triangle, so I guess the right angle, and then two pieces of information, you can solve for any of it. So if I go to solve for the opposite side, I can use tangent.
4.0. Thought I got it right.
So, what's your setup? So check your setup here. We would have tangent of 15 equals that opposite side, let's call it z,
I put the wrong angle measure.
over 15.
Yeah.
So to get this by itself, it's just 15 times tangent of 15.
Yeah, I got
So the opposite angle always go in tan.
Opposite does not relate to an angle. Opposite is a side. The angle is your theta. Opposite, adjacent, and hypotenuse are all meaning sides.
How do you define theta? Because you said theta was just
Theta is the angle you're looking at. It's just whichever angle you choose. Can't be the right angle, but I could choose either of these. Because if I come up here and use this angle, this has to be 75.
Yes.
So then I could say tangent, and this is what Steven was telling you to do, like turn the triangle in the red one. Tangent of 75 is its opposite. The 15 is now the opposite side over the z because that's now my adjacent side. Either way works. Because sine will be
Wait, is sin and cosine one be on our test, right?
sine and cosine will not. It might be like an exemplary option. But it won't be like a required to get mastery. Thomas?
You have two triangles, and you know that two sides are congruent, and you have right angle on both of them. Can you use angle side?
No. Angle side's a bad word. We can't use it.
Wait, two sides congruent, and you have.
Not so a side on each of them is congruent. If you have two on each of them, then we can use side angle side.
Yeah.
But if you just have one matching pair of sides, and then you know two matching pairs of angles, no, because I could change which side gets, like, it all depends on location, right? So if I have, like, 5 as my matching side, and then 2 angles, I could rebuild the triangle, putting the 5 in a different place, and it changes the triangle.
Well, I'm meaning.
I know why angle side
And then one of the works.
Then you have 2 sides, and it's side
It's
angle
all
side.
common.
Yeah, but the angle
Which
is
you sit down.
I did a
the
mind
only
thing.
angle you know is the right angle.
That's the
I
only
did a
angle.
mind thing.
Yeah, the only angle you know is the right angle.
If the 2 sides are on the right angle, then yes. If they're not, then no. You can't do that. You have to figure out one of the angles. You have to figure out your angles. But if we know how to work the trig, we could probably figure out the angles. If you know 2 sides, you can figure out the angles. Either 2 sides. Santia, sit in the desk. Do you realize that you're in front of people right now? Like, people can't see through you.
They're right there.
Yeah, but I do. Like, that's not appropriate classroom behavior for someone to just be like, I'm gonna, like, be like, I come here and I'm like, alright, so now we're doing, like, it's not cool.
Ooh, math.
Alright, can we move on from now? Like, can we just
Yes.
stop worrying ourselves about the trig?
No.
Specialize.
Hold on. I'm still gonna need some review.
How are we supposed to find the hypotenuse of green?
Use sine or cosine.
Already
So
think
once, once you know,
Cosine.
wait, will you let me delete? Apparently not. Once you know your other side, like we can solve for using tangent, you can do whatever you want. But where we stand right now, Chris, to directly answer that question, we have, what is this compared to the 15? If I look at the 15-degree angle, what is 15 feet, or whatever length that is? Is it adjacent, hypotenuse, or opposite?
Adjacent.
Adjacent, right? Because if I'm looking here, it's adjacent. Then if I'm trying to solve the hypotenuse, I'm now thinking about adjacent and hypotenuse. That directs me to, I gotta use cosine. Because if I had the opposite and the hypotenuse, I gotta use sine.
Is it
So-
hypotenuse over adjacent?
Why don't you just use Pythagorean theorem?
We could,
Is
but we're-
hypotenuse over adjacent?
You're smart.
SOHCAHTOA tells you the order. Sine, top, bottom. Cosine, top, bottom. Tangent, top, bottom. So for cosine of 15 degrees, because we know it, is the adjacent side of 15 over the unknown, what we're trying to solve for, hypotenuse. And we just solve the ratio, the proportion.
What's their third grade you understood trig at Wellington?
Probably. It's just a skill that once you learn it, memorize what it does, it's not like it's deep conceptual math. Understanding why it works, which I'm putting an emphasis on that, that's harder than understanding what it's like, how to plug it in and get your... You could give somebody one worksheet with very detailed, like, here's your opposite, here's your adjacent, here's your hypotenuse, and they could understand trig by just working through a series of problems.
So can you give that worksheet to me?
No, because I'm not trying to get you to just understand how to do the calculator trig. I'm trying to get you to understand what trig is related.
I don't...
So if you're referencing like a third grader that gets it, they don't understand the conceptual of what it's doing. They understand how to type numbers in a calculator. What about the conceptual don't you understand? Forget about sine and cosine. If somebody walks up to you and they say, hey dude, my math teacher talked about tangent. Do you understand? That's it.
Well, I know what
Richard, I need you to stop. As soon as you get on a roll, either you or Steven decide to interject yourselves. And I love that you guys are trying to help, but if, we are having a conversation, jumping in isn't really going to help. Clapping isn't going to help, because he was trying to continue speaking.
I know the conceptual then, but I don't know how to plug it in.
What do you mean?
I don't know how to, I always choose the wrong angle, or I always choose the wrong side whenever I do.
Did you do your closure?
Oh, yeah.
Last week? Did you check your answers?
Yeah, I got them right, but that was because of Steven and his help.
Here, I'll write down buttons.
So I think you lost some of your confidence because you were looking at the wrong pages last week when we were doing this. And you were typing in things wrong in your calculator because we were doing one problem up here and you were looking at a different problem down there. So I think you should do drill. Just because I think you get it. I think you don't think you get it, but I think you get it. Which is a dangerous place to be, right? So we've made some time and made some really good forward progress. So this is worth taking the time to make sure he's confident.
I'm sorry, guys.
Actually, it's fine. You don't have to do chapter 4 yet.
Should be something.
And yes.
Yeah.
And hardware.
Okay,
If there comes up with a Comcast, I'll free.
All right, kiddos.
Please do this one.
If we only know tangent, right? Hopefully this lets us just use tangents.
Oh.
Here, from A,
You do it.
what would tangent of angle A equal? Satya, because we're trying to do this for you. Sorry, Steven, I'm guessing you know it. Satya is the one who's asking for more practice.
Tan of A equals... No, it would be
Here's where you're
12
getting stuck.
divided by tan of A.
Here's where you're getting stuck. When we first talked about it, we always had the angle here.
Yeah.
Right? And we always had run
Yeah,
and
run and rise.
Right? So if I, in my brain, make that angle be slope angle, right? Like angle of elevation, then the 35 is now over here, the 12 is here, and the 37 is here. But you don't need to have your brain stuck with the angle having to be at the bottom left, because from A, draw a line. What is opposite A?
35.
Then what side is left that isn't the hypotenuse?
So it'd be tan of A times 12?
No.
So what you just told me is tangent of A, and this was a couple minutes ago, you said slope ratio, right? If I set it up as slope ratio, the rise is 35 and the run is 12. If I'm trying to compute A, I got to inverse the function. So I inverse
find
tangent
out
those.
35 and just be tan A times 12. Inverse tangent.
We're not trying to find 35. Okay? What you just said is to find 35.
No, I mean to find... So what are you trying to find?
A. We are trying to solve for A, the degrees of it.
Yeah.
But the ratio it equals is 35 over 12. If I reduce this down, that's my slope. Physically my
A,
slope.
you do tan to the power of
Inverse
-1. Inverse tan equals rise over run.
Not inverse tan equals rise over run. Inverse tangent, and you plug in your rise over run. So we have to set up the initial. Hey guys, can you be a little bit quieter, please? We have to set up the initial function and then figure out how to isolate the variable we're trying to solve for. Here to isolate A, I have to get it out of tangent, so I apply the inverse. I do the same thing on this side because we have to according to our rules of algebra.
Oh, yeah.
So in our calculator, we type in inverse tangent, and then we plug in the ratio. It will spit out the degrees. Okay?
But now if I wanted to find 35, should I always rotate it to be
You
like that?
can't find 35 right now. Like, if you didn't have 35,
is 35.
you stop.
That's obvious. 35 equals 35. I know that. I'm talking about the side of CAD. That's a B. That's a B.
If you were handed this triangle, only using tangent, you can't do anything right now.
Really?
If we only use tangent. Because
Oh,
we
yeah,
don't
I
know any of the
angle
angles, aside from the right angle, and we only know one of the legs, right, and then the hypotenuse. But that's where the other trig functions come in. If I could use, cosine. Cosine relates the adjacent of the angle to the hypotenuse. So if I'm still looking at A, I have its adjacent, and I have the triangle's hypotenuse. So I'd be stuck using cosine for that one, but we're not there yet. You either have to know the legs to find the angle, or an angle to find one of the legs.
But if we knew the angle, would it be tan of that angle?
Okay, so give me an angle. Tell me, like, we still don't know 35.
50.
Then actually we should.
Actually, that
So
one works.
this is not 35.
Yes.
Okay, which let's
Oh, no,
make that up.
It's
We-
side CB.
And this is not 37. Let's just say that doesn't exist either. But this angle is 30.
Yes.
Okay. So to find CB, we set up the original. Don't overthink. Just set it up. Don't try to do anything until you set it up. Tangent of 30 equals opposite. Don't know it. Over adjacent. I do know it.
Okay.
Then figure out how to solve it. Quit trying to think how to get to the solution before you write anything down.
Tan of
Bless you.
Yeah.
You cannot just try to go straight to your calculator. You will make mistakes. You will screw it up.
So
You
will it,
have to write out the
will I
original.
ever have to find out the angle?
Will you what?
Will I ever have to find out the angle measure of the third angle that's not provided?
Yeah. Once you find out one, you know the other.
You know the other because of
Yeah, but will I ever have to use that angle to find it out?
Yes, you will eventually. We use all parts of it. Yeah.
I think I understand this. I don't think I'll get a math on the test though, but that will be helpful.
But that's the point behind it.
That's why we're at meetings.
Huh.
We do our homework.
Don't fear it.
We haven't
I
done
don't
any of the
understand it.
lesson.
Fear it.
Just press the buttons that it says you press.
So
Very dysfunctional.
if you want, honestly, it might be beneficial for you to go back here and just watch Khan's video on this, because having somebody else explain it, and especially like how I know you learn, you can just put headphones on, tell your dudes to go away, and just like watch Khan explain trig. That would probably be helpful for you.
Okay.
If you're still at all like wanting clarification, just listen to his explanation, because it's a different person, right? Different perspective, and he's a brilliant mathematician. So yeah, I mean, and if you listen to him talk, he's just brilliant in general. And I very much agree with his goals. Like, I want to provide free education opportunities to anybody in the world. All right, 411, 411, which is also a type of gravel.
Oh yeah.
Interesting.
Yeah, you don't care. All right, so factoring expressions. What? 411 is a type of gravel. Like rocks, like 57, nines, there's like a bunch of numbered names for the gravel. I'm sure there's a reason why it's called 411 or 57 or nines or like,
Nine.
I think there's also like 17.
Would it be this?
Yes, and there's an intro video that happens before that, I think.
Oh, so just like this entire page?
Yeah,
I was
and
gonna
so
favorite this.
if you were trying to teach yourself trig, you'd start here, watch 2 videos, do some practice, actually I forget what those are. But then this is the practice that you were just looking at. That one.
I just,
All right.
gonna do that.
Now, kind of selfishly, I sort of want to utilize you guys to help me with a current objective, but not at the moment. Sorry, I just had the idea pop in my head. So, factoring. And actually, Mr. Hall and I were discussing this morning. Did you guys use algebra tiles back in Math 1 last year? I know people who took it over the summer probably didn't.
I'm pretty sure I saw that some of it. I already know how to do that.
Okay. So this is where, and Mr. Hall and I were kind of having like a disagreement, but that's good. Like when people push you to like, his question was like, how purposeful are algebra tiles in understanding the idea of factoring? And I felt as if they were very purposeful. And because he's been teaching longer and has done things before we have algebra tiles, kind of disagreed. So we went back and forth. And what it really comes down to is if I asked you to factor a quadratic trinomial, right? And we watched the quadratic formula song. Like, we could use the quadratic formula to find out zeros. But what are the zeros? What does the factor form mean? And what the heck does any of this represent is why we use the algebra tiles. So, when we talk about an expression, any expression, we can represent it physically, right? Any math expression can have a picture, diagram, whatever you want to say that goes with it. So we talk about the expression x squared plus 13x plus 40. I could set up my little multiplication triangle and, sorry, not triangle, my multiplication rectangle. What did you say?
Sorry, you just said something about how any math thing can be related as a diagram.
Yeah.
What about each of that? What about that thing? I don't know what it is.
Do you understand what you're asking?
Not
Is it on topic right now? Would it be better to be another time? So, if we were given x plus 8 times x plus 5 and told to represent that with a picture. Well, okay, if I make a rectangle that has a length of x plus 8. I don't know what x is, but I know how to count 8, right? So I could set up a length of x, whoop, and then 8 of these, and get my x plus 8. Then the other direction, I'd have to also have a length of x. So crap, instead of using one of these, I'd actually be using an x squared and have a length of x going up, and then 5. So visually, when we go to do this, we have one length, I don't know, or actually one square, so I'm going to be doing this, but I need some space to write, a square of size that we're not aware of. This, I forgot that in Smartboard, I could make it bigger or smaller. But then I have 8 that I do know. So we'll call that 8. But we do not know what this is at all. It's x by x.
X squared.
Yeah, but lengths, right? We're talking lengths right now. Then this is 5. So this region right here is 5 tall, x wide. Okay, so the area of it, right, is 5 x's. This area over here is 8 times x. And then this area up here, 40, and this is x squared. This is why we use these. That's why we use the multiplication rectangles, to break down the areas that would physically exist when multiplying with non-like terms. Okay, now we're going to start to go backwards.
Wait, what?
So going forwards, we could build a rectangle of length we don't know, length we do know, length we don't know, length we do. And then you can find out the area after we build it.
Not finding it. You give your area, find the shape.
But now, if you're given the area and asked to figure out the shape, things get a bit trickier. So this is where we start physically using algebra tiles. So, and this is actually extremely coincidental that we had this conversation this morning, because he came to me to ask about this, and like we're doing this today. 2 days.
And that was like
The only way to factor accurately, you try to keep your bags with each other, but you'll tell very, you don't need 2 bags. No. The only way to factor it out pure is if it can make a rectangle. Right? So if we're missing any parts, we need to readjust how the rectangle is made.
But you figure out all about looking at them.
So 2x squared plus 7x plus 6.
Do you see X quartile?
Blue is X.
Blue is x, yes.
That should be possible. At least every square.
So we're not trying to make a square, we're trying to make a rectangle.
What the heck? Find X squared, that would be nice. This game doo-doo. This game doo-doo, brother.
Here comes my hoodie.
And you do have a 5 set. There is like 5 ones connected in there.
I know. Okay, gotcha.
Yeah, this is possible.
Yeah. I think I got it.
I don't feel like cutting down the line though, so I'm not gonna. My fingers are imaginary.
So my 2x squared, right? They can either go beside each other or like this. This wouldn't really probably make any sense if I don't, like if I offset them, because my length of x is a shared attribute, right? So then if I start trying to put my x's somewhere, I should line them up with shared attributes. So either on top or off to the side. So if I just throw a couple on top, and then these out to the side.
That wouldn't work. Oh, I did mine another way.
Yeah,
That's
me
not
too.
how.
I did mine 2 by 2.
Oh, I did mine like this.
So what if
Yeah,
What
this
does
doesn't
it
work.
work?
4, 5, 6. Oh, I didn't want to have to.
this doesn't work, right? Because I have 1, 2, 3, 4, 5.
For 1, 6, 7.
That won't work, right? Because I have 1 left over.
Oh, you do?
So
Wait,
change
is
it.
plus 10? What is it? Plus 10?
It's up on the
Plus
7x plus
Plus-
6.
No, you just
Up on the TV now.
move those two to the bottom of the X square.
Okay.
I don't know why I can understand most stuff in math, but trig just kills me.
Satya, move on for a moment. Just let it go, man. Be like Elsa.
Oh, that was
That's
terrible.
not okay.
You are correct. I'm not here to be okay. I'm here to push your mental, cognitive, thinking, ability.
Mr. Hudson
Processing.
signing off. Little bit.
So, I can build it, right?
Yeah, something like that.
I can't use a 5 tile. That doesn't like the connected tile. I got to break them up. But I got my 2x squareds. I got my 7 x's, and I got my 6 ones. What is the factored form of this quadratic?
2 squared plus 7x plus 6.
Did you say 2 squared?
2x.
Still not correct.
How is it not correct? Oh, never mind.
2x plus 3, x plus 2.
Which is equal
Right?
to 2x.
Now, hold up. I don't have very long.
Oh, the whole like product and something.
Now, here, gonna blow your mind. Here's the quadratic formula. The quadratic formula finds our zeros. But what that actually means is when will this figure sum to nothing? So what it's asking are zeros in a quadratic. Are when does the area of this become nothing? Okay, I'm talking slow for a reason. So we know this area is 6. So what we would then have to make happen, what should all of this become? -6, which physically doesn't make any sense to us.
Because it's like the way that it looks. It's like
Because how could we have a negative area? But I can shrink x smaller, and I can even make x negative. Not fit, like it won't physically work here. But when we find out that the zeros here are negative 3 over 2 and negative 2, if the length of x became negative 3 halves, or if the length of x became negative 2, this will destroy itself and become 0. Now, I'm going to connect it even further. On a graph, when I go to graph the parabolic arc formed by 2x squared plus 7x plus 6, I really need to have something better to write on than that screen.
Yeah.
This is better than a graph that I could make, so it's worth going to Desmos real quick. 2x plus 7x plus 6, that's what we have, right? Or 2x squared plus 7x?
Yeah, x squared plus 7x plus 6. Wow.
This line is your area. This quadratic, this parabola, is showing you the physical area of your algebraic tiles. So what that means is in this space, the shape doesn't actually exist. Right? Between negative 2 and negative 3 halves, I can't actually have that object. But anywhere up here, it exists. So when I plug in an x of negative 1/2, even though that doesn't really make sense, it would have a positive area. But when I plug in realistic values, I left my other pen over there. When I plug in realistic, like positive lengths, what does my area start at when x is 0? Well, 6, right? As I increase my x value, like if I make the length of x 5, my area, now sometimes this is hard to solve, so we set up on our graph, okay, x is 5, find that intersection. Right, and we just had to, now my area gets huge, absolutely ridiculous, because I have 2 5 squared regions now, and my, like, what do we say, this is now 5 by 1. This is now 5 by 1. This is a 5 by 1. That's a 5 by 1. Like, the area gets huge. If we make, like, I don't know, x1, it's a little bit more reasonable.
Yeah.
And Desmos will give you that intersection point real easy. That is all the time we have for today, so please put the algebra tiles away. We will pick up that lesson tomorrow and continue on the same stuff. If you want to do me a favor, throw your bag of tiles in the box over there.
You shall not punish me, all shall follow.